Hello and welcome to Scholar Fedu. This is our UTME prep series where we provide relatively detailed solutions and explanations to the UTME questions. And in this recording, we are looking at the UTME questions for chemistry for the year 2017. This is the last part of the recording where we are going to look at the next 20 questions in that year. Before we continue, please don't forget to subscribe to our YouTube channel, like and share our content. You can also visit our website at scholar.com to practice the UTME exam and modular quizzes for free. Alright, first question here. Which of the following separation processes is most likely to yield high quality ethanol, that has a purity of greater than or equal to 95% from palm wine? That will be by fractional distillation without the use of a dehydrant. Okay, fractional distillation without the use of a dehydrant is going to yield or produce high quality ethanol. Next, the products formed on hydrolysis of this compound here in acid, that is in hydrochloric acid, is that will be what we have here. Okay, this compound here, the hydrolysis of an alkanoate is going to produce an alkanoic acid. Okay, an alkanoic acid and an alkanol. To produce an alkanoic acid and an alkanol. Next, in the reaction, this reaction here, how many electrons are transferred for each mole of copper produced? Alright, electrons are transferred to the copper in this reaction here. Okay, 1 mole of copper contains 6.02 times 10⁻23 particles. Each mole of the copper ion in copper oxide, in this copper oxide, is going to gain 2 electrons to become reduced to copper. So 2 times what you have in 1 mole is going to be equal to 12.04 times 2 raised to the power 3. This is 1 mole. This is for 1 mole. 6.02 times 10 raised to the power 23. So for 2 moles, okay, 2 moles, that will be 2 times 6.02 times 10 raised to the power 23, and that will be equal to 2 times 6.02 is 12.04. Now this 12.04, I can borrow a 10 from here. If I borrow a 10 from here, that's like dividing this by 10. I will get 1.2. Then I'll now add that 10 to this one here. So this will become 10 raised to the power 24. Okay, so you have 1.2 times 10 raised to the power 24 particles. Next, the electronic configuration of an element is this. How many unpaired electrons are there in the element? Alright, just like in the previous question that we solved on this here regarding the fluorine, what we'll do is we'll draw the diagram of the orbitals of these elements here, and that is what we have here. So you have the 1s2, 2s2, 2p6, 3s2, and 3p3. Okay, 3p3. If you now look at this last orbital here, we can see that in all the other orbitals, the electrons are paired. Okay, the electrons are paired. But if you look at these orbitals here, we have 3 unpaired electrons. This electron is not paired with another. Okay, same with this and this as well. So you have 3 unpaired electrons, alright, in the p orbital of these elements. Next, 8.0 gram of an element X reacted with an excess of copper 2 tetrasulfate 6 solution to deposit 21.3 grams of copper. The correct equation for the reaction is alright, the atomic mass of copper is 64 gram. The given mass of copper in this question here is 21.3 gram. That's the deposited mass of copper here. What we are going to do is find the number of moles of the copper that is produced by 8 grams of X. Okay, this X, alright, when this element X was reacted with copper sulfate, that was when this was produced. So we want to know what is the number of mole of copper that is in this. So that will be equal to the given mass of copper, which is 21.3, divided by the atomic mass of copper. So you have 21.3 divided by 64, and that is 0.3328. So 8 grams, that 8 grams of X produced is 0.3328 grams of copper. Now y grams of X, we want to know how many grams of X is going to produce 1 mole of copper. So we set up an equation, okay, a ratio rather. We are going to have 8 grams over y gram is equal to 0.3328 over 1. If we cross multiply, the denominator here will multiply the numerator here, the denominator here will multiply the numerator here. So we are going to have 8 times 1, alright, equal to 0.3328 times y. 8 times 1 is 1, that will be 8. 0.3328 times y will be 0.3328y. To get the value of y here, we are going to divide both sides by this coefficient of y, which is 0.3328. So that means we are going to have y is equal to 8 divided by this, and that will give us 24.0 gram. So that means that the molar mass of that element X is 24.0 gram, which would, since the element is just one element, it's not a compound, this will also be the atomic mass of that element. Okay, and 24.0 gram is the atomic mass of magnesium, and this is the equation of reaction between magnesium and copper sulfate. Alright, magnesium and copper. So we have identified that X here to be magnesium. Alright, so if we now go to our option, we just relate it with what we have here. If we relate it to what we have here, that means instead of magnesium here, they are using X. Okay, instead of magnesium, so we are going to have 2X plus copper tetraoxosulfate to form what? To form this. Alright, copper and that, let's say this is magnesium tetraoxosulfate in reality, since we have identified X here to be magnesium. In the manufacture of iron in the blast furnace, iron 3 oxide is mixed with coke and limestone, and different reactions occur in the process. Which of the following statements is true with respect to these reactions? Okay, one of those things that happen during the production of iron, okay, in the blast furnace, is that limestone is added, and that limestone decomposes under heat, okay, to give calcium oxide, alright, and carbon dioxide. This calcium oxide then reacts with impurities. It reacts with the earthly impurities, alright, that is the silicate and the aluminum oxide, to form calcium silicate. It reacts with the silicate to form reacts with the silicon oxide to form calcium silicate. Okay, so that is one of, so this is true regarding the reaction. All right, so at one of the levels of the reaction, we have the calcium carbonate or the limestone decomposing under it into calcium oxide, that's quicklime, which then reacts with silicon oxide to form calcium silicate. Okay, the electrons of two elements Y and X are arranged in shells as shown above. The bond formed between the atoms of Y and Z is, so if you look at this atom Y here, it has 4 electrons in its outermost shell. The atom Z here has 7 electrons in its outermost shell. Now the best way to answer this question would be to determine the elements whose atoms are represented as this. And how do you do that? Is first we are going to find the atomic number, and that is by counting the number of electrons that we have here. Alright, so here we have 2 electrons, here we have 8, and here we have 4. 2 plus 8 plus 4, that will be 14. And 14, that's the atomic number of silicon. Okay, for this one here, we'll count, we have 2, 8, and then 7, that is 17, which is the atomic number of chlorine. So that means that the element Y is silicon, the element Z is chlorine. What is the bond that is formed between silicon and chlorine? It is a covalent bond. Okay, where there is pairing of electron between the silicon and the chlorine atoms. Next question on gas laws. A gas sample with an initial volume of 3.25 dm cube is heated and allowed to expand to 9.75 dm cube at constant pressure. What is the ratio of the final absolute temperature to the initial absolute temperature? So this is a question on the relationship between volume and temperature. Now remember, by Charles' law, that volume and temperature vary directly. Okay, the volume and temperature of a fixed mass of gas at a constant temperature is directly proportional. So the ratio of the final temperature to the initial temperature will be the ratio of the new volume to the original volume, and that would be 9 point. Since this is direct proportionality, so you can say the ratio of the final to the new temperature is equal to the ratio of the new volume to the initial volume. Okay, so we are going to have, so final to initial, not final to new. The final to initial is going to be the ratio of the final volume to the initial volume. So that will be 9.75 ratio 3.25. That is 9.75 divided by 3.25, and that is equal to 3. Alright, that will be 3. So the ratio of the temperature of the final temperature to the new temperature is 3. That is 3 to 1. Next, the chemical used for coagulation in water purification is, so coagulation is one of the first major step in the process that water would undergo, okay, before it is supplied to homes for domestic use. What coagulation does is it helps to coagulate the big particles, the big dirt particles in the water. Coagulating here means that it helps to bring them together, like to clump them together, to form heavy masses with them, so that these particles can now settle in that water, okay, and they can be easily filtered. And for that process, the substance, the chemical used is aluminium tetraoxosulfate. There are other substances too, like potassium alum and sodium aluminate. Okay, so alums basically are used for the process of coagulation or flocculation. Aluminum tetraoxosulfate 6 is one of such chemicals that is used to coagulate the dirt in water. We have a website at scholar.com where you could practice exams for free, the UTME exam and the post-UTME exam. It also features modular quizzes in physics, chemistry and biology. So if you've studied a topic in any of the subjects and you want to test your understanding of the topic, you can head on to our website at scholar.com and take modular quizzes for free. Also, if you sign up on the website, it has a personalized dashboard where you could use to check your progress in learning. We also have interactive sessions on the website and on our social media platform. Freebies are also available to top performance on the website. Next, a liquid will dissolve a liquid that will dissolve fat is, alright, fat is an organic compound and it is a polar substance. Polar substances will dissolve in polar substances. Non-polar substances will dissolve in non-polar substances. So this fat is going to dissolve in a polar substance like kerosene. Next, when air, which contains the gases, you have oxygen, nitrogen, carbon dioxide, water vapor and rare gases, is passed over alkaline pyrogalol and then over quicklime, the only gases left are, alright, air is a mixture of these gases that we have here. Now, passing the air over alkaline pyrogalol is going to eliminate the oxygen in it. Okay, the alkaline pyrogalol is going to remove the oxygen in it, while this quicklime here, okay, is going to absorb the carbon dioxide and water as well, because it is a deliquescent or an hygroscopic substance. It will absorb this water vapor and this carbon dioxide. So the only gases that will be left with from this, okay, in that mixture is nitrogen and the rare gases. Next, the number of atoms in 1 mole of a substance is equal to, alright, the number of particles, okay, like atoms in 1 mole of a substance is equal to what we call the Avogadro's number. Alright, and that number is 6.03 times 10 raised to power 23. Okay, so that is that 1 mole of a substance, okay, of an element, for example, is going to contain 6.03 times 10 raised to power 23 atoms. Alright, which of the following terms indicates the number of bonds that can be formed by an atom? That is the valence. Okay, the valency, or what we call the is the number of valence electrons in an atom. That is the number of electrons in the outermost shell of that atom, and that number determines or indicates The structural formula of ethanoic acid is, the ethanoic acid is CH3COOH. Okay, CH3COOH, and the structure here is what you have here: CH3 combined with, that is this alkyl group here, connected or connected to carbon atom, which is then bonded to an oxygen atom here and an hydroxyl ion here. Okay, so it is this here, CH3COOH. That is the structural formula of ethanoic acid. Environmental pollution is worsened by the release from automobile exhaust of the release of smoke. Okay, smoke which contains carbon monoxide, okay, is a pollutant. It's a pollutant. It is harmful to human health. Okay, when it is inhaled, it can affect the respiratory tract. You can also join our online tutorial classes for different classes. We have tutorials for students in SS1, 2 or 3. We also have for UTME candidates, for JAMB candidates, for students who want to write the JAMB or the UTME exam, and for those who want to have the post-UTME exam after the UTME exam, and also for candidates that are sitting for WAEC exam or GCE or NECO. And we offer this tutorial on various platforms, so you could join us on WhatsApp or on Telegram, you could be on Zoom or on Google Classroom. So we have various platforms where we take our tutorial. The links to join the platform are available on our website at scholar.com, or you could also check it out in the video description below. Next, on acid, base and salts. What volume of the 0.5 mole per dm cube sulfuric acid will exactly neutralize 20 cm cube of 0.1 mole per dm cube sodium hydroxide solution? That's caustic soda. So first, what we are going to do is we are going to write the chemical equation of reaction. Okay, and that is the sulfuric acid reacting with the sodium hydroxide to produce sodium sulfate and water. Okay, this is an acid base reaction, okay, giving a salt and water. Now the focal point here is that in this reaction here, 1 mole of the acid has reacted with 2 mole of the base. So the number of moles of the acid in this reaction here is 1. The number of moles of the base here is 2. Alright, from the question, the concentration of the acid is given as 0.5 mole per dm cube, while that of the base is 0.1 mole per dm cube. Also, they give us the volume of the base here as 20 cm cube, but we are not given the volume of the acid, and that's what we are required to find in the question. So we then recall this formula from stoichiometry. So CAVA, this should be A, over CBVB is equal to NA over NB. That is concentration of acid, volume of acid, concentration of base, volume of base, number of mole of acid, number of mole of base. So if we go back to this data that we have here from the question, and we substitute, we'll be having concentration of the acid is 0.5, okay, volume of the acid, over concentration of the base, which is 0.1 times the volume of the base, which is 20. I've just changed the order here, sorry, pardon, equals the number of mole of the acid. Okay, that is gotten from the equation of reaction. This is not given in the question, we get it from writing the equation of reaction. So we have 1 mole of the acid over 2 moles of the base. So here 20 times the 0.1 is 2. We can multiply this 2 here, so we are going to have 0.2 times 2. So we are having a 0.5 VA equals 0.5 times 2, which is 1. To get the value of VA, we divide both sides by 0.5. So VA will be equal to 1 over 0.5, and that is equal to 2 centimeter. So the volume of the acid here that will be used to completely neutralize this base in this question here is 2.0 cm cube. Which of the following is an electrolyte? So electrolytes are molten substances or liquids that can conduct electricity, and from this option here, the sodium acetate is an electrolyte. The sodium acetate is an electrolyte. This is its chemical formula. Next question: which of the following would greatly increase would introduce the greatest increase in the rate of the chemical reaction above? Alright, generally an increase in temperature and in the concentration of the reactant would increase the rate of a chemical reaction. Okay, an increase in concentration will increase the rate of the chemical reaction, and an increase in temperature is also increase the rate of the reaction, because in both the forward reaction would be favored, okay, or the reaction in the other side is going to be favored, okay. Increasing the concentration of the reactant is going to favor the production of the product, okay, like that. Now in talking about the temperature, another thing that we need to consider is whether that reaction is exothermic or endothermic. Okay, whether it's exothermic or endothermic, that will determine whether it is the forward reaction that will be favored or the backward reaction that will be favored. Where the forward reaction is favored, the rate of the chemical equation would increase. Okay, where the backward reaction is favored, the rate of the chemical reaction is going to reduce. Okay, unless you really consider that phase, okay, where it is favored, then you can say it is increased either ways. Okay, which of the following substances has the lowest vapor density? So what we are going to do is, for all of these compounds that we have here, we are going to calculate their molar mass. The one that has the lowest molar mass or molecular mass is going to be of the lowest vapor density. So we start with the ethanoic acid. This is the chemical formula for the ethanoic acid. How do you get the molar mass of the ethanoic acid? We are going to add the atomic masses of the elements that we have in it. So we have the atomic mass of this is what we've been given already. Atomic mass of oxygen, of chlorine, of hydrogen, and carbon. So we'll come here. For carbon we have 12 plus. For hydrogen it is 1, but we have 3 of the hydrogen here, so that is 3 times 1 plus carbon again, that is 12 plus we have oxygen and there are 2 of it here, so you have 16 plus 16, or you could have simply said 2 times 16 then plus the atomic mass of hydrogen, which is 1. By the time you add up all of this, you are going to get 60 gram for the ethanoic acid. Okay, the next one, the propanol C3H7OH, you are going to do the same thing. So for it, 3 times the atomic mass of the carbon plus 7 times the atomic mass of the hydrogen plus the atomic mass of oxygen, which is 12, plus the atomic mass of hydrogen, which is 1. When we add up all of this, we'll be getting 56 gram. We will do the same thing for dichloromethane. 12 plus 2 times the atomic mass of hydrogen, which is 1, and 2 times the atomic mass of chlorine, which is 35.5. So here this is giving us 85 gram. The next one is ethanol CH3CHO. 12 for carbon plus 3 times 1 for hydrogen plus 12 for carbon plus 1 plus 16, we are getting 44 gram. So look at which of this one here, okay, which of this is which of this has the lowest molecular mass, okay, the lowest molecular mass, and that is ethanol. So ethanol is going to have the lowest vapor density. Final question: the presence of impurity in a substance will cause the melting point to. Alright, the presence of an impurity in a substance is going to reduce, okay, the melting point, while it will increase the boiling point. Okay, it will reduce the melting point and increase the boiling point. Okay, don't forget to check out our playlist. We have different playlists. We have for full solutions to UTME or JAMB questions and in physics, chemistry, and biology. We also have for modular quizzes as well. Okay, we'll also have a playlist for post UTME or post JAMB exam, and also for crash courses in physics, chemistry, and biology. So don't forget to check out our playlist for the available videos. So that's it for this recording. Thank you very much for watching. Please don't forget to subscribe to our YouTube channel at ScholarFedu. Okay, like and share our content, and visit our website at scholar.com to practice UTME exam and modular quizzes for free. Thank you.